Good morning, one and all, and welcome to my viewers. Today we will discuss about formation of linear equation. Now, why it is called linear equation? This thing will come to know later on. First of all, we will discuss a few basic things, how to form a linear equation. Now let's discuss a few basic concepts before coming into formation of linear equation. One is constant and variables. Now let's imagine the series of even number 0, 2, 4, 6, 8, 10, 12, etc. Now recall the multiplication table. 2 multiplied by 0 equal to 0. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, etc. Now see in this series, the first column is only 2. From top to bottom it is only 2. The second column we see it's a variation. It is increasing from top to bottom, right? So if you generalize this second column with a symbol, say for example n, we try to mean this series. We generalize this series with a symbol n. That means every time you are multiplying n with 2 to obtain a even number. So when you are considering n equal to 0, twice n equal to 0, 2 into n means 2 zeros are 0. When you consider n equal to 1, 2i's n equal to 2 multiplied by 1 equal to 2, you got the second even number. When you consider n equal to 2, 2i's n equal to 2 2s are 4, that means you got the third even number, and so on. Again you consider another example. Say 2 multiplied by 0 plus 1 equal to 1. 2 1s are 2 plus 1 equal to 3. 2 2s are 4. This line 2 2s are 4 plus 1 equal to 5. Right. Then this line 2 3s are 6 plus 1 equal to 7. 2 4s are 8 plus 1 equal 9. Then 2 5s are 10 plus 1 11. 2 6 are 12 plus 1 equal to 13. Now in this series, the first column is again constant. It is remaining the same, no change. So we call it constant. Third column, it is again constant. It is remaining the same, 1 1 1 1 every time. But the second column, you see, it's a variation. Values are changing downward. Now if you generalize this column with x, so what we find that you multiply 2 with x, then you add 1 to obtain an odd number. So when x equal to 0, you find that twice 2 into 0 plus 1 equal to 1, you will find the first odd number. Then when you consider x equal to 1, 2 1s are 2 plus 1 3, you got the second odd number. When you consider x equal to 2, you multiply 2 to the 4 plus 1 5, you got the third odd number. When you consider x equal to say 3, twice x plus 1 means 2 into 3 plus 1 equal to 7, you got next odd number, and so on. So what we understood is a constant is a term which remains the same throughout a mathematical operation. Every time we are considering 2, then again considering 1 to obtain an odd number. We cannot change this number to obtain odd number. We are only changing this second term, means x. Right. Similarly in this case, every time we are changing the values of n. This first column, it's remaining the same, 2. So constant is a term which remains the same throughout a mathematical operation, whereas variable takes many values, right? Now this type of expression, twice x plus 1 or twice n, this type of expression, twice n or twice x plus 1, these are called algebraic expression, and we call them every term of the algebraic expression, we call them term. Every part means it might be sum of two terms, it might be a single term. Later on in case of polynomial, we'll call it as a monomial. It's a single term, only one term. It contains two terms, we call it binomial. Later on we'll discuss these things. Now here we call 2 is called coefficient. In this algebraic expression, 2 is called coefficient. 2 multiplied by n, twice n. Whereas n is variable, here x is variable, 2 is called coefficient of x. Means term multiplied with x, variable, is called coefficient. Coefficient is written in front. So if you write 4x minus 3, it's a binomial, it's an algebraic expression with two terms, and coefficient of x is 4. Here is a constant term is 3. 4 is also constant. Here 4 is coefficient. Now let's form algebraic expression. We will discuss a few examples from Cbse books. Say for example, oranges are to be transferred from a larger box into a smaller box, into smaller boxes. When a large box is emptied, the oranges from it fill two smaller boxes, and still 10 oranges remains outside. If the number of oranges in a small box are to be taken to be x, what is the number of oranges in the larger box? Oranges are transferred from a larger box into a smaller box. So for example, it's a larger box. Oranges are there. Now we will shift these oranges to smaller boxes. These are smaller boxes, right? So oranges are to be shifted from this larger box to this smaller box. Not exactly two boxes, might be many boxes. So we are trying to shift oranges from larger box to smaller boxes. When a large box is emptied, when you find this empty, entire oranges are shifted to smaller boxes. From it to fill smaller boxes, two smaller boxes, and still 10 oranges remain outside. If the number of oranges in a small box are to be taken to be x, what is the number of oranges in the large box? So smaller boxes can hold how many oranges? X number of oranges. Here it says if the number of oranges in a smaller box are to be taken to be x, this box can also hold x number of oranges. So we filled two smaller boxes. In two smaller boxes, how many oranges we filled up? X plus x equal to 2 times of x, right? So we filled up capacity of smaller box equal to x. In two boxes, we filled x plus x, that means twice x. Now it says after smaller boxes are filled up, still 10 oranges remains outside. Means they don't have capacity to hold the entire oranges in the larger box. 10 oranges are still remaining outside. So what is the total number of oranges? Total number of oranges is total number of oranges equal to number of oranges in the smaller box twice x plus number of oranges remain outside 10. That means this larger box, it contained twice x plus 10 number of oranges. Therefore, the larger box contained twice x plus 10 oranges. Right? This is the answer. What is the number of oranges in the larger box? Twice x plus 10. We find that smaller boxes can hold x number of oranges. Now it says only 2 boxes are filled up. Then after the 10 oranges remains outside. 2 boxes can hold x plus x twice x number of oranges. 10 oranges remain outside. When you emptied the entire box, when you shift entire boxes, you find that these 2 boxes can hold x plus x twice x number of oranges. After that, 10 oranges remain outside. 6, 9 plus 1. 10 oranges remain outside. So what is the total number of oranges? Twice x plus 10. Twice x plus 10. So that was the capacity of the larger box. Right. Next, we will discuss one more problem from Cbse book. Leela is Radha's younger sister. Leela is 4 years younger than Radha. Can we write Leela's age in terms of Radha's age? Radha's age to be x. So there are 2 girls, Radha and Leela. There are 2 girls. It says Leela is Radha's younger sister. That means she is younger. Her age is less than Radha. Right. So what is Radha's age? Radha's age, it is to be considered as x. Now Leela is younger than Radha. So what is the number which is 4 less than 8? Suppose if I say what is the number which is 4 less than 8, we will write 8 minus 4 equal to 4. What is the number which is 4 less than 8? The answer is 4. What is the number which is 5 less than 7? 7 minus 5 equal to 2. Answer is 2. What is the number which is 5 less than 7? The answer is 2. Now Leela is 4 years younger than Radha. So what is Leela's age? Leela's age, you find Radha's age minus 4. Since Leela is younger than Radha, so Leela's age is x minus 4. So we write Leela's age in terms of Radha's age. We do not know exactly what is her age, so we only try to find Leela's age with comparing Radha's age. Radha's age is x, Leela is 4 years younger, so Leela's age is x minus 4. Leela's age x minus 4 years. This is the answer. Now we will discuss one more problem of Cbse book. This we will try to find from triangle with matchstick. Try to form triangle with matchstick. Let's form a triangle. So you need 3 sticks to form a triangle, right? Now we actually try to form adjoint triangles. Means we'll be joining triangles like this. Now you see, for two numbers of triangle, ideally you should have considered 6 sticks, but ideally you should have considered 6 sticks like this, right? 6 sticks, but we don't need 2 sticks here, we are replacing 1. For forming 2 triangles, we are replacing 1 stick. Now let's form another triangle, adjoint triangles here. Ideally, you should have considered 9 sticks for 3 triangles, right? For 3 triangles, you should have considered 9 sticks. One here, this triangle, and here. Now we will replace these 2 sticks. They don't need, right? Again, for forming 4 triangles, let's form 4 triangles here. Ideally, for 4 triangles, you should have considered 12 sticks, but here we are replacing how many sticks? 1 is from here, 1 is from here, 1 is from here. That means we are replacing 3 sticks. Therefore, for one triangle, you are considering 3 sticks, right? For 2 triangles, we are considering 3 multiplied by 2, but we are replacing 1 sticks from here, means we are subtracting 1. We are taking away 1 sticks. For 2 triangles, we are taking away 1 sticks, like this. There were 2 sticks here, we are replacing 1 sticks. That means for forming 2 triangles, we are using 3 multiplied by 2, 6 sticks, but we are taking away 1 sticks. Now for forming 3 triangles, ideally you should have considered 3 multiplied by 3, but we are replacing 2 sticks. One is from here, one is from here. We are replacing these 2 sticks. That means we are subtracting 3 triangles. Similarly, for 4 triangles, 3 multiplied by 4, we will replace 3 sticks, and so on. For 5 triangles, 3 multiplied by 5, we will be replacing 4 sticks, and so on. So now you consider this pattern. This number, it is a constant. For one triangle, we are using 3 multiplied by 1 sticks, but we are not replacing any stick. We are replacing 0 sticks. One triangle, you are using 3 sticks, and you are not replacing any stick, right? 0 sticks. Only for starting from 2 second triangles, you are starting from second triangle, you are replacing stick. First time you are replacing 1 stick. For 2 triangles, you are replacing 1. For 3 triangles, you are replacing 2 sticks. You are taking away 2 sticks. That means minus. Taking away means minus. Now you try to explain this in terms of mathematics. So in terms of variables, say in the first column, you see it is 3 only, right? In the second column, it is varying 1, 2, 3, 4, 5, right? So what we understood is, if you consider x number of triangles, then what would be the situation? We try to generalize this variable series. We try to generalize this with variable x. If you form x number of triangles, or if you form any number of triangles, n number of triangles, then what would be the situation? For 5 triangles, you are multiplying 3 multiplied by 5 and replacing 4. That means 5, it is 1 less than 5. For 4 triangles, you see 3 multiplied by 4 minus 3. Then that means for 4 triangles, you are replacing 3 sticks, means 1 less than the number of triangles. For 3 triangles, 3 multiplied by 3 minus 2. You are replacing 2 sticks. That means 1 less than the number of triangles. Now for x number of triangles, x triangles, you will find that 3 into number of triangles minus how many sticks you will replace? One less than the number of triangles. That means x minus 1. So we find that for x number of triangles, you find that 3 multiplied by x minus x minus 1. You will replace this number of sticks. That means you got 3x minus x. Then you minus, additive inverse of minus 1 is plus 1. So you find that twice x plus 1. So this matchstick pattern these adjoint triangles, right? So this matchstick pattern we try to explain in terms of variable. This is 3x minus x minus 1, 3x minus x plus 1, twice x plus 1. We try to generalize this pattern of triangle. So if you put any value, then you will find the number of sticks required for making the triangles. For example, if you put x equal to 1, say for example x equal to 1, if you put x equal to 1, 2x plus 1, this means 2 into 1 plus 1 equal to 3. That means you will get one triangle. When you put x equal to 2, then you find that 2 multiplied by 2 plus 1 equal to 2 to the 4 plus 1, 5. That means you find 2 triangles. If you put x equal to 3, 2 into 3 plus 1 equal to 7. That means you will find 3 triangles, and so on. Now let's discuss the formation of an equation. Say for example, you consider this statement: sum of the twice of a number with 10 is equal to 5 times of the number plus 6. Now let's try to form algebraic expression from this statement: sum of the twice of a number with 10. Now we do not know the number, so let's assume let the number be x. Let the number be x. So what is the twice of the number? Twice of the number is twice x. Twice of the number, right? And sum of the number, twice of the number with 10. So twice of the number means twice of x plus 10. Sum of the twice of the number with 10. Twice of the number plus 10. That means sum of the twice of the number plus 10. Now next statement is 5 times of the number plus 6. So what is the 5 times of the number? 5 times of the number is 5x. Now sum of the 5 times of the number with 6 means 5x plus 6. Now this statement says that sum of the twice of the number with 10 is equal to 5 times of the number plus 6. This means these two statements are equal. It says twice x plus 10 equal to 5x plus 6. So we form an equality between two algebraic expressions. One is twice x plus 10, another is 5x plus 6. We form an equality, and this is called an equation. Now the equation is constituted by forming equality in between two algebraic expressions. Now it contains three parts. One is left hand side one is right hand side, left hand side we call it LHS, and right hand side RHS, and there is a sign of equality. This is called sign of equality, right? Next we will try to form another equation. Say for example, twice of a number with 1 is 5. Twice of a number with 1 is 5. Twice of a number with 1 is 5. Sum of the twice of a number plus 1 is 5. So how to form an algebraic expression from here? Twice of the number is twice x plus with 1 means sum of the twice of the number with 1, and the result is 5. Now we constitute an equation by forming equality in between an algebraic expression and a constant, right? This time we are forming equation by comparing an algebraic expression with a constant. Again, think about another statements. Say for example, square of a number when subtracted from 25 is 0. Now think about this statement. Square of a number, let the number be x, so square of the number is x square. Now when square of the number is subtracted from 25, this means x square is subtracted from 25. 25 minus x square. Now the result is 0. Square of a number is subtracted from 25. Now the result is 0. This time we form an equation by comparing an algebraic expression with 0. Right? We compared an algebraic expression with 0. So we can form equation in 3 ways. We can form equation in 3 ways. Forming equality between two algebraic expression like this. Twice x plus 10 equal to 5x plus 6. Here we are forming equality in between two algebraic expression. Second time we are forming equality in between an algebraic expression with a constant 5. Third time also we are forming equality in between an algebraic expression with a constant, but this time it is 0. So there are 3 ways to form equation. Now in this chapter we will talk about linear equation. This is not a linear equation. This power of x is 2, degree of the polynomial. This polynomial, later on we will call it a polynomial, means 25 minus x square is a polynomial. It is actually binomial. The degree of the variable is 2, so it's a quadratic polynomial. Now in this chapter we will talk about formation of linear equation. So what we have learned, an equation has 3 parts: left hand side, the sign of equality, and the right hand side. Right? We will discuss about solution of linear equation next time. So let's wait.